So before we start that, let me ask you guys, what is a square root? What is a square root? Or let me rephrase, what is a perfect square? What is a perfect square? Yeah.
Something like you could multiply to get the number that you want.
Okay. Yeah, it's kind of hard to like describe it, right? That makes sense to me. Reggie, what are you thinking? You agree?
Yeah.
So maybe you could come up here and move one of these.
I can move it.
Yeah, you can move it. I want you to move one of them that is a perfect square into the perfect square column. So just touch the number and move it. So find one that's a perfect square. Good. All right. Okay. So Reggie says 81 is a perfect square. Do you guys agree or disagree? Agree? I agree as well. Why is 81 a perfect square? 9 times 9 equals 81. So I can multiply what kind of number is 9? 9 is it's odd, that's true. It is a square root, so that's kind of a weird one. That's crazy. So it's not prime, but it is odd. What else is it? Is it a decimal or a whole? It's a whole number. So a whole number times itself gives you 81. So I have some other numbers up here. Some of them are perfect squares, some of them are not. And I want to shuffle them into columns. So I need 7 more people to come up and move these numbers. So I need 7 people to come up. Go ahead. Reggie, you already came up. Diamond, you can come up. Go ahead. Ashley. Go ahead, Alan. Emily. Oh, only one person touch the board at a time, though. Can I get 2 more? All right, Reggie, come back up. Yeah, they left you with the hard ones.
I know, right?
Yeah. Good. All right. Can you finish that one? Do you think that one is or isn't? All right. Nice. Okay. Anybody disagree on any of these? Don't disagree. Okay, these are all correct. So everything here is correct. These are all our perfect squares, and these are all our quote-unquote not perfect squares. So when we say they're perfect squares, that means there's a whole number you can multiply. So that means I can take the square root of 81, and it gives me what? 9. Because the square root means what number multiplied by itself will give you this number. What does a square root symbol look like? Kind of like a division with just like a little tail, right? So it's like a division house with a little tail. So what's the square root of 49 then? 7. What's the square root of 25? 5. What's the square root of 169? 13. Good. And what about 225? Close. 15. Good. 15 is the square root of 225. Perfect. So that means if I do 15 times 15, what does it give me? 225. Good. 225. Okay. All right. Why is 15 and 32 and 72 not a perfect square? Ashley? I didn't hear him. Wasn't listening. You go.
Because there's nothing that, is a perfect square. Does it have like the same number?
Okay, so the same number multiplied by itself, I want to agree with that because that's almost perfect, except it's missing one word. So nothing, all those numbers on the perfect square, all the square roots have what in common? They're all what kind of number? 9, 7, 15, 5, 13. They're all odd numbers, okay, but we could do like 16 and it would be 4 and that's still perfect. But they are all what kind of numbers too? Whole numbers. They're all whole numbers, right? Is there a number that you could multiply by itself that would give you 32? Not a whole number, but is there a number? Yeah? What kind of number would it be? A mixed number, or so either a fraction or a decimal. Typically, if we look at it, we're going to look at it like it's a decimal. What kind of decimal? Does it stop or does it keep going? Does it have a pattern or no pattern? No pattern. Does anyone remember what we call a number that goes on forever, but it doesn't make sense and there is no pattern? Irrational. Very good. So the square root of these imperfect numbers is irrational. It will be irrational. So, could you do it? Yes. But what kind of number will it give you? A decimal number that goes on forever and there is no pattern. Because remember, guys, what does irrational mean? If I told you, quit it, you're being irrational, what would I be saying about you? You might be over-exaggerating, over-dramatizing. Okay, you're being a little weird, right? You don't make sense. So irrational numbers are those numbers that don't make sense. You can't predict what's going to happen next. It's a decimal number that goes on forever with no pattern. So there is a square root of 32. It's just going to be irrational. Okay, so it's going to give you a decimal that goes on forever with no pattern. Okay, so let's try some of these. These are all perfect squares. So for the first half of the lesson, we're just doing perfect squares. So what is, let's start on the easier end of this. What's the square root of 81? Square root of 64? Square root of 225? Square root of 441? I'm hearing different guesses. I know it has to be bigger than 15. How do I know that? I know it has to be bigger than 15. How do I know that? 225 is lower than 441. So the square root has to be bigger than 15 because this number is bigger than that number. Okay, so you think 17? All right, how could we figure it out? Not divide. Multiply. So Reggie's guess was 17. I heard a lot of other guesses, but let's go with that. So 17. So how would I check to see if 17 is the square root? I would do 17 times 17 because it's a number times itself, right? Okay, what's 7 times 7? Carry the 4. That's, you already said it's not going to be at y. How do you know that? No, hang on. It's not necessarily because we're over, but it has to end in a 1. This is going to end in a 9. We're going to keep going with it, but keep that in mind because that's really important. What John Jacob just said, no, it's already wrong. Okay, 7 times 1 is 7 plus 4 is 11. 1 times 7 is 7. 1 times 1 is 1. So that's 289. So are we big enough or still too small? Still too small. Now remember, it has to end in a 1. So I need it bigger than 17. And it's got to be something that ends in a 1. So what are my options? 19 is an option. Why? What's 9 times 9? 81. So that's going to end in a 1. So 19 is an option. So we would check that by doing 19 times 19. What's another option? 21. Because 1 times 1 is going to give you... Okay, I'm going to pick this one because it's easier. All right, 1 times 1 is, 1 times 2 is, 2 times 1 is, and 2 times 2 is. All right, there goes our answer. So the answer to this is square root of 441 is 21. Okay, so if it's a perfect square and it's bigger than what you're familiar with, you know it had to be bigger than 15 because you already know that one is 225. And you know it has to end in 1. So your options for ending in 1 are either 9 times 9, because that's 81, or 1 times 1, because that's 1. Okay? So when you go to do the practice on the next slide, there's a lot of them that are large numbers. So you're not going to want to just pull numbers out of a hat. You want to go about it in an educated way. So if your number is bigger than 441, then you know your square root has to be bigger than 21. So don't waste your time doing things like 16, 17, 18 because you know it's going to be bigger than that. So my suggestion, because there are 16 of them on the practice, my suggestion is do the easy ones first and try to use those to help you place the other ones. Okay? All right, so go to your boards. We're going to take probably 12 minutes on this. If you don't finish, that's okay. Okay, overall, if you were to tell somebody, like, what's a strategy for how to do some of those really big ones? What's a strategy for how to do some of those big ones? Look at the last number. Okay, so you want to look at the last number because that'll help you know what, like, the second digit might need to be in your square root. Good. Okay, use the ones that you've done before too, right? So if you know that 900 is 30, which pretty much everybody got pretty quickly, then you can work from there for some of those other big ones. But what do we do if it isn't a perfect square and I say I want you to approximate it? So first of all, what does approximate mean? Close enough. So approximate would be close enough. So I want to round it off because, like we said, if it's not a perfect square and I was letting you use a calculator, if you did it, it would give you a long decimal, right? But we don't want to do a long decimal. We just want maybe one place or two. But let's look at this square root of 32. It's not perfect, right? There's no whole number that gives you 32. But how could we approximate what decimal number it might be close to? So how would you go about doing this? And again, calculator not an option right now. So how would you go about doing this? What do you think?
Find a number that does equal.
Okay.
So then you can find like between two. So like basically find two numbers and then find one.
Find two numbers that it's in between. What kind of numbers? I totally agree. What kind of numbers? Find two perfects that it's in between, right? Okay, so before we do this, let's make a list of our perfects. So the smallest perfect is, what's the square root of 1? 1, so that's a perfect square. All right, square root of 4 is 2. What would be next? What would be my next perfect? 9. What would be next? 16. What would be next? Why 25? Good, because that one's going to give you 5. What would be next? Next. Good. 121 gives you 11. 144 is 12. And let's do one more. Gives you 13. Okay. All right. So these are the most common perfects that we're going to be working with because it's going to be in between those most of the time. You know how to figure out bigger ones because you just did it, but these are the ones that are most common. Now, most of you guys probably know at least up through 10, right? You probably at some point learned up through 12 because whenever you do times tables, you can learn up to 12, okay? So these are the perfect squares that we're going to work with. So let's go back to what Marina said, which is I want to look for two perfect squares that this is in between. So where would 32, square root of 32, fit in my list of perfects? Daniel? So right in here, right? So it would fit somewhere in here. It would fit between 25 and 36, the square roots of those. So that means this number, let's imagine this is on a number line. Is it going to be closer to 25 or closer to 36? A little bit closer to 36. So I'm going to put it like right here, a little bit closer to 36, square root of 32. Well, what's the square root of 25? And what's the square root of 36? So what two whole numbers is it in between? It's in between 5 and 6. So what are some numbers that are in between 5 and 6? 5.5, 5.6, 5.7, 5.8, any of those, right? Any of the decimal numbers in between 5 and 6. But I want it to be closer to 6. So give me a decimal that's between 5 and 6, but closer to 6. 5.8. Good. We're going to call that our approximate square root, 5.8. It's closer to 6, but it can't be bigger than 6, because if it were bigger than 6, then this would have to be bigger than 36. All right, so it's got to be smaller than 6. So sometimes when I think about this, I think about what's the money in between $5 and $6. all right, and $5.80 would be between those. Is this exactly right? If I do it on a calculator, is it going to give me 5.8? No, okay, but is it close? Probably, all right, so when we're talking approximate, sometimes you'll see like a wiggly equal sign like that. That means approximate because it's close, but not quite there, all right, and when I ask for an approximation, that's what I'm looking for, some decimal that's close, but not quite there. All right, this list of perfects that you might have memorized, might not have memorized, will come in very handy when you're doing this. All right, for me, I still like to have the visual. So for instance, if I do square root of 107, this is going to be between what two perfect squares? It's going to be between the square root of 100 and the square root of, what's the next one then? 121, which means it's between 10 and 11. Is it closer to 10 or closer to 11? Closer to 10. So if you were going to give me an approximate, what would you give me here? Maybe something like 10.3. Okay, 10.3 might be approximately the square root. That might be a little too big, I'm not sure, but that's a good approximation, okay, because it's closer to 10. Questions on where we got those from? All right. So ignore what's on this slide just for a second. What if I gave you this? This is an expression. It has no equal sign, so it's an expression. I can't solve it, but I can simplify. How would I simplify this? What part would I do first? Solve the square roots first. So if I want to solve those square roots first, what would it give me? 10 plus, good. And that gives me 15. So when you're doing square roots, they act in order of operations. Does anyone know what letter they go with in PEMDAS? No, they don't. It seems like they might. Exponents. They go with exponents because how do I write something squared? How do I write like 5 squared? 5 with a little power of 2. So the square root's just the opposite of that. So exponents and square roots go hand in hand, which means in order of operations, you do these when you do the e's. All right, so in PEMDAS, it comes second. So do that before you do any of the addition, subtraction, multiplication, or division. All right, it also, this is way easier, 10 plus 5, than trying to find the square root of 125, okay, which is not going to give you the right answer anyway. All right. What two whole numbers would this one be in between? Why? Good. So it's between 25 and 36. So this would be between 5 and 6. Okay, don't shout out. What two whole numbers would this be in between? I want a new hand, a new voice. A new hand, do not shout it out. I've seen your hands, I've heard your voices. I want some new ones. Whole numbers would this be in between? Hannah? 9 and 10. Why? Okay, so it's between 81 and 100, right? So it would have to be between 9 and 10. All right, what about 5? What about 5? What would 5 have to be in between? 1 and 2? Or 2 and 3? Why 2 and 3? What's 2 squared? 4. And what's 3 squared? 9. So 5 is in between 4 and 9. All right. This one would be closer to what? This would be closer to 2. This one would be closer to 9. And this one would be closer to 5. Good. Okay, so at your boards, I want you to pick, no, I lied because we're running short on time. So I would like you guys to just do the exit ticket. There are 2 questions. The first one just says what 2 whole numbers would be in between. And the second one is simplify this expression. Once you show it to me, there are templates up here if you did not get one. Once you show it to me, then you can grab your socket marker and put them up.